Okay everyone, I got inspired to explore some other types of graphs. Why not? There's so many different types of graphs. We've talked about, what, 5 of them? We did line graphs, we did bar graphs, we did histograms, we did pictographs, and we did pie graphs or circle graphs. And we did double this and triple that and all that kind of stuff. But there's also, lots of other types of graphs as well. So I thought we'd just look at a few of them. Now, the only one of these that I would say is really important is the first one, the scatter plot. In terms of graphs that you're likely to see in math class or in real life. It's not true. You're going to see other ones in real life too, but I guess I'm thinking more math class. Sorry. So the scatter plot. Well, believe it or not, we actually kind of already did a scatter plot. So I just want to be really clear what it is and give you an example and like that. So what's a scatter plot? A scatter plot uses dots to represent values for 2 different numeric variables. So what we're going to look at for our scatter plot, we're going to look at ice cream sales versus temperature. And what a scatter plot does is it allows you to observe if there's relationships and maybe even causation between variables. Causation is when one thing causes another. So think of this, we've got the temperatures outside, and then we've got how much ice cream is sold. Do you think there's a relationship? I bet there is. Do you think one thing causes another? I would say so. What would be your guess? You'd probably guess that as the outside temperature gets warmer, hotter, you sell more ice cream. So, from looking at the numbers, you might be able to get a sense in the chart. But a scatter plot will help us to actually see for sure whether it's the case. It's basically like a line graph, but the things don't line up in a perfect line. And we did do this before. So here's what we're going to do. We're going to try a scatter plot for this data right here. And I don't want to do it by hand. Now that we've seen how easy it is to do it with a spreadsheet, I'm going to use a spreadsheet. So I'm going to go back to Google Sheets. Here it is, and here is the exact data that you were already looking at. First column is the temperature in degrees Celsius. I should have degrees Celsius there. And the second one is sales in dollars. So just like last time, I'm going to highlight all this. That's what I'm interested in. Then I'm going to hit the insert chart button. It probably, it did. It gave me a scatter plot right there. Scatter chart, they call it. It looks pretty good. I might just switch a few things. I'll change the title to ice cream sales versus temperature. Bold that. Make it red. Now I could start the minimum value at 0. See how it starts at 12 here, and it kind of makes sense because the smallest value is 12. I could start it at 0, and it would look like this. But maybe that's not such a good idea on this one. I'll remove that from now. I might put it back later actually, and maybe I'll add some more grid lines. Okay, I think that's pretty good. Now the idea with a scatter plot is, as you can see, these dots do not make a one line, right? It goes up a little more, down, up. So what we might want to do though is take our best guess of what a straight line would look like if it went through here. Well, guess what? Google Sheets will do it for you. You go to Series, and under Series there's one that says Trend Line, and if you click Trend Line, it'll give you the line of best fit, it's called. So it uses pretty advanced mathematics beyond the scope of Workplace 11, and it'll figure out mathematically what's the most accurate line that goes through all those points. Now, as you can see, it actually doesn't go through any of the points, but this is the best line that gets as close to all those points as possible. And this line's really useful because now we can see the trend. As the temperatures get higher, what's happening to the sales? It's also getting higher. The line is going up and up and up. Now, I'm going to go back and actually make that horizontal axis. I'm going to click this. I'm going to make the minimum 0 because I think it actually is interesting in one sense. So here, I've changed it to 0. There's something kind of interesting to note right here. Right at around 5, a little bit more than 5, maybe 6. Right around 5 or 6 degrees, the trend line hits the bottom there. What would that mean? That would mean at 5 or 6 degrees right here, you'd expect sales of 0. You're not going to sell any ice cream. I mean, if you're an ice cream person, an ice cream seller, this would be good information to know. That if the temperature is below 6 degrees, don't bother going out in your truck. But then again, there's no actual data points down there. So what are we doing right here when we assume that it would be 0 here? We are extrapolating, right? Because it's beyond the points here. And that was the topic when we talked about scatter plots before, when we did extrapolation and interpolation. But I just wanted to reinforce that because it is an extremely important type of graph, especially in math and science. Okay, let's look at another type of graph. This one's called a stacked bar graph. So yes, it is a bar graph, but it's a stacked bar graph. So what does that mean, a stacked bar graph? It's like a double or triple or quadruple bar graph, but the bars are literally stacked, one either on top of each other if it's a vertical bar graph, or if it's a horizontal bar graph like this one, they're stacked side by side by side. I don't know why the word bar is bolded here. Sorry about that. Each bar in the chart represents a whole, and segments in the bar represent different parts or categories of that whole. So let me explain what that means. So this graph here shows male ages in different countries, and there's a lot of information. So let's just look at the first one here, the United Kingdom. If you wanted to know how many males are in the whole United Kingdom, you would look at the end of the bar. So I would look right here, and I would say in the United Kingdom there's, just under 30 million, probably 28 or 29 million males in the United Kingdom. Now, if I wanted to know how many people are between 0 and 14 years, how many boys are between 0 and 14 years, I would look at the end of the blue one. So what's that? Around half would be there. About 7 million. About 7 million boys are between 0 and 14 years. Now, here's the tricky part. If I wanted to know how many boys are between 15 and 64 in the United Kingdom, you're probably thinking to yourself, I just go here and I read that number, right? No, because this bar has been stacked on top of that one. What I actually need to do is figure out how many males are represented between these two bars. How many males are represented in this orange one? So I think for this reason you can see already a triple bar graph would be a lot easier to read here. I guess the only way you might want to use the stacked is if the total, remember we found the total was like 28, 29 million? If you want the total, this would be very useful. If you want to compare the little groups, the different groups, I think a triple bar graph would be better. Anyway, if I did want to know the number of males between 15 and 64, I would take this number, which looks like it's right in the middle, about 25 million, and I'd subtract this number, which I'm just going to say is right in the middle there, about 5 million. So 25 million, take away 5 million, means there'd be 20 million there. So it'd be about 20 million here. We already said that this was around 5 or 6. I'm going to go with 5. And then to get this top bit, you'd say, well, it went up to 29. Remember the total was 29, and this was at 25, so there must be about another 4 million here. Add them all up, you get the 29 million. So, it's not the easiest graph to read, but these are graphs you will see from time to time. So let's answer a few questions. Number 1, what's the most common age group in Brazil? So Brazil is right here, and we want to know what's the most common age group. So really, all you have to do here is look at the bars. What's the biggest bar? Blue, orange, or gray? Orange is definitely the biggest. Orange is 15 to 64. So if you're not actually interested in actual numbers, this can be, a good graph to use. If you want actual numbers, it's not as great. How many boys are between 0 and 14 years of age in Russia? So Russia is right here, and we want 0 to 14, which is the blue one. Oh, okay, the blue one's the easiest one to do, isn't it? Because for the blue one, you can literally look straight down from the end of it and just read how much that is right there. So I don't know, what's that, around 12, 13 million? I'll say 13 million. How many men are older than 65 in the USA? So here's USA. We want older than 65. That's the gray. So don't just do this. Don't just measure that. If you get that number, let's say that number right there is, what, pretty well right in the middle? 135, maybe 136 million, 136 million. Is that the number of 65 plus men in the United States? No. What's that number represent? All the males in the United States. So we got the 136 million for all the males. Now, if we also get this amount right there, which is right around 120 million, I would say, what would we do with those two numbers to get how many people are actually in this gray area over here? If this is 136 million and this is 120 million, if we were to subtract those numbers, you'd be left with the amount right there. So that's what we do. We subtract that. 136 minus 120 is 16, and it's still million. So there are approximately 16 million men older than 65 years old in the United States of America. Okay, next one, an area chart. I don't like these, but you do see them quite often. I've seen them in the papers and magazines a lot, so I'll go through it. I think these can lead to being misleading. We're going to talk about misleading graphs next time. So an area chart is really just a type of line graph, right? Why don't they just draw lines for here, line for the orange, line for the blue, and you'd have a triple line graph, and that'd be great. I think it'd be easier to read. Now, they're used to compare multiple quantities. So in this case, they're comparing the population of bears, dolphins, and whales. Seems kind of odd to have dolphins and whales, oh yeah, living in the oceans, and bears. Oh yeah, a lot of bears out there. Anyway, and then the last thing is they can be stacked or they can be unstacked. So let's imagine first that this is unstacked. If it was unstacked, this would just be like a line graph. So for example, I'm just going to take a few points. In 2019, that would be the point, and that would be the point, and that would be the point, right? And if you wanted to know if this was unstacked, and we wanted to know how many of each species there were in 2019, we'd just measure across from here for our, what's gray? Whales, and we'd say, well, there are 200 and approximately 25 whales. For what's orange? Dolphins, there's about 125 dolphins, and for bears, there is approximately, I don't know, what do you say, 90? About 90 bears, and we'd be done. And that's not too bad, and that's unstacked. But let's imagine this is stacked again. So this is just like what we did in the last question. So then you could start actually by getting this amount, which would be exactly the same. What did we say for the bears? We said around 90 million. Now, for the dolphins, we'd go up to here, and we said that was 125, right? But if it's stacked, that doesn't mean that there's 125 dolphins. That means the number of dolphins is the number that takes you from 90 up to 125. So how many do you need to have to add to 90 to get 125? You need to add 35. So there would be 90 of the bears, 35 of the dolphins, and then to get the whales, you'd go up to the top. We said that was, I believe, 225. And you'd ask yourself, what do you have to add on to the 125 to get 225? You have to add on 100. So there'd be 100 whales. See the difference between unstacked and stacked? Unstacked is really easy to read. Stacked is a little bit more difficult. Now, one of the things I don't like about these graphs, sometimes just by looking at it, like this one right here, I don't know whether that's an unstacked or a stacked graph. It doesn't actually tell me. But let's just imagine that this is a stacked graph. You knew I was going to do that to you, make it harder. What's the most abundant species in 2017? So that's the first year here, right here. Now, what many people will say is that the most abundant is the one nicely at the top here, which is whales. That's the most abundant. No. The one that's the most abundant is the one that has the highest span to it, I guess. So this is how many whales there are, but look at how many dolphins there are. All those. I don't know the exact number, but that's definitely bigger than this. There's hardly any bears at all in 2017. So dolphins is the most abundant. How many bears were there in 2019? Oh, again, we love this because bears is the lowest one, and whether it's stacked or unstacked, it's very easy to read. 2019, I think we already got this number. 2019 is right there. We go up from 2019, over from there, and I think I'm just a little bit too high there, about there. And I think we already said that it was around 90 million. Sorry, 90 million bears. Wow. Bears everywhere. So 90 bears. What is the total anticipated population of all three species in 2022? Oh, okay, so we're going to 2022 into the future. I guess this is what their guess is. And we want to know what the total number of species if we were to add all three of them together. Now, here's one way you could do it. Get how many bears there are, how many dolphins there are, and how many whales there are, and add them all together. But is there a way to do that in one step? There absolutely is. Just go straight to the top and go over from there, and whatever that is, that's going to be the total number of all the species. Well, it's just a tiny bit more than 250. I'll go 255. So that's the area chart. Last one, the radar chart. I never saw this before. I love it. This is so cool. So what a radar chart. I mean, look at this thing. That looks so crazy. A radar chart is used to plot one or more groups of values over multiple common variables. So what that means is we're going to look at either one thing, or in our case, we're going to look at three things. We're going to look at three gymnasts. Carol does gymnastics, Brenda does gymnastics, and Amelia does gymnastics. And they do some kind of routine. Let's say it was a floor routine in gymnastics. And then they get marked on 5 different things. They get a mark for how difficult their routine was, how well they executed it, how well they did their landings, the style they employed, and how creative it was. And believe it or not, this graph right here shows all Carol's 5 scores, all Brenda's 5 scores, and all Amelia's 5 scores. It's not the easiest thing to read, but it's kind of cool that you're able to do that. So, who did the hardest routine? Well, hardest routine has to do with difficulty, right? So how do you figure out who did the most difficult and the least difficult? You look out, they have all these concentric circles here. And if you have a dot right here, like this poor blue person did, Brenda, her difficulty level was only a 1. Not very difficult. She did like 1 somersault and 1 cartwheel, and that was it or something. I don't know. So she got a 1. This is the next one right here. That is the orange one, or red or pink or whatever that is, and that's Carol. She got an 8. But the most difficult one at all was this 9 right there, and that was Amelia. Amelia had the hardest routine. I'm going to put in brackets 9 because that was her score. All right, next. Who was the least creative? Well, creativity is here. The most creative person was this. What did they get? You have to follow it around. Oh, that was a 9. Who got that? Oh, again, Amelia. Whoa, what a routine for Amelia. Next, least creative was this one, which was on the number 7, right? If you went around, it intersects here at 7. So that was the pink one, which is Carol. And the one that was the least creative, I'm not so impressed with Brenda here. No difficulty, no creativity. What did she get? She got a 5. Not that bad. So Brenda was the least creative, and she got a 5. All right, last thing. Let's get Carol's total score. So for total score, we have to add up all her scores. Carol is pink, so we're going to add on that one, that one, that one, whoa, and that one. Does Carol have style or what? So let's add those all up. For difficulty, we already talked about this. Carol got an 8. Plus, we got to add them all up, right? For execution, didn't do very well. A lot of mistakes. She only got a 3. You can either look like this or you can count out from the middle. 1, 2, 3. She got a 3 for execution. Plus, for her landing, again, didn't do the greatest. She's in here, and that is at a 4, I think. 1, 2, 3, 4. Yep, a 4. For style, I mean, she aced it. She's right at the outer circle, which is a 10. And for creativity, she is a 7. So we're going to add them all up. 11, 15, 25, 32. She gets 32. Oh, don't you want to know who won? I do. I'm clear that Brenda lost. But who won between Amelia and Carol? It must have been Amelia. My guess is Amelia. I can't help it. I got to figure this out. Okay, here's Amelia. She's a 9, a 6, a 9, 6, and then a 10 for landing. Very good. 9 plus 6 plus 10. Then she's a 7 and another 9. What a score. 41. Kills the competition. Okay, here's Brenda. This is going to be embarrassing. She got a 5, 1, 9. Good with the 9 there. And then she got another 5 and an 8. So she gets 28. So she was actually closer to Carol than I thought she would be. But Amelia is the big winner. Well done, Amelia, and well done to all of you. And sorry about the dryer in the background. Have a good day. Take care.